What's up, guys? Here we go with section 6, new unit. We're going to finish this chapter really at chapter 2, but we're going to kind of lump together the section 6, and I'm going to show you what this section is all about with a little YouTube video. And I'm going to preface this by telling you I'm not endorsing this particular company. It's just an example and an analogy that I'm going to use when we go throughout doing what we're going to do in this video. So let me play this video for you. Hopefully you can hear it. If not, yeah, I'll at least type in for you down here or show you what the actual YouTube video is that you can type it in and watch it on your own if you can't quite hear it. So here you go. Enjoy.
Hey man, what's up? No, dude, I'm just down at the bottom of the slope. Yeah, you should have seen this killer run I just had. You should totally see it. No, hold on. Hold on. No, I just have, there's like, holy. Dude, you would not believe who's standing right behind me. It's the Can You Hear Me Now guy and the network. Oh my god. Dude, am I being punked? What? Are you serious? What are you guys doing here? No. You don't believe me? I'm serious, man. I'm not even kidding. Which lift are you going to? Yeah. I mean, I'm not quite sure what this is. I have an entire network following me.
Surprising guy. It told me yours too.
They're seriously following me everywhere I go. This is no joke. Man, I didn't even know you guys were real. I thought you were like unicorns or stuff. You know what I mean? No, they're definitely still following me, man. They stop when I stop. They stop when I stop, man. The network's all. Did you see that wide gnarly spill I just took? It's gonna be pretty dope. Yeah, hold on. I'm just about my board right now. No, how can you not believe me? I have an entire network following me everywhere.
That is so cool.
Alright. Alright. Yeah, did you see that? Yeah, just take a picture with them.
Hey, can you hear me now?
Dude, I don't know what the weight limit on this lift is. So I'm not sure if all you guys can go. Okay. I'm gonna go now. Bye, network.
Verizon Network, can you hear me now? Now, just so you know, that YouTube video is entitled Verizon Network Snowy Surprise. So if you want to go watch it, you can. And here's the title, if you will, I guess the essential question for section 6. How do you graph linear inequalities? Notice it doesn't say linear equations. We're talking linear inequalities. And I'm going to use this Verizon network that's standing back here on your screen. I'm going to use that analogy to help you understand how we actually do go about graphing linear inequalities and what it looks like. So this video more is focused on what the idea is behind linear inequalities and solutions to that, so what they need to look like. Then the next video, a short little video, will be an example and the steps of how we actually do it. So let's dive into this. Now, let's compare what a linear equation is compared to a linear inequality. And it says, here's a thinker question. What is the difference between, the key word though here is it says, the solutions. What's the key difference between the solutions to these two things? And that's what we're going to focus on here. So when you look at this one, this here is a linear equation because there's an equal sign there. This is a linear inequality. It's pretty simple. That's how you tell the difference. But what are the solutions to these things is the key thing to understanding the whole idea. So if I ask you to find the solution to this equation, you could do this and say, hey, let me make an XY table. Yeah. And I'll just start putting in like -4 here and see, I'll choose X. I'll plug it in and evaluate this and see what I get for Y. You could put a 0 in there. You could put a -2 in there. You could put a +2 in there. You could just come up with all of these. And they would be solutions to the actual equation. Another idea would be to graph it. If we just graph this guy, you could kind of cover this thing up right here. I almost did it with my hand. That wouldn't have done any good. You wouldn't have seen that, regardless. If I kind of cover this up or put a 0 in for x, that would mean y would be a 6. Cool. So right there, my y-intercept would be at 6. Cool. And if I cover up or put a 0 in here for y, that would mean x is negative 2. So you could put that right there, and you could graph the line down through it. The other option would be to put this in slope-intercept form. Some of you might choose that. That's fine, again, if we're looking to graph the equation here, this linear equation. So, if I do that, I'd add 3x to both sides, which would give you this. So I have y equals 3x plus 6. I know you know this. You'd say, okay, let's start with the y-intercept at positive 6. So when I graph that, bam, there it is. Then you would use your slope of 3 over 1 and go up 3 over 1 and get your next point. Bam, there you go. Just like that. And then you can keep going up 3 over 1, but I ran out of graph. So you can go down 3, back 1, down 3, back 1, down 3, back 1, down 3, back 1, and you get the graph. It looks like that. So all of those particular points, guys, would actually be something maybe in your t-chart, your XY table, or they're really just this. They are just solutions to this equation. Because if I take this one, say 1, 9, if I put 1 in there and I put 9 in there, does it work? Yeah, because I get negative 3 here plus an actual 9, which would give me a 6. So that right there is a solution to the equation. Now here's the scoop though. If I graph this particular line, bam, there's what it will look like. So here's the idea. Boy, this might be the first that you're actually hearing this. The reason that you're graphing this line and connecting all the dots, because this line represents every single dot that you actually have. I'll make a whole bunch here. Bam. So this dot right here, that particular ordered pair, this particular ordered pair, all of these ordered pairs that I'm pulling over here, every one of these, all of these dots represent ordered pairs that would be a solution or solutions to this particular equation. Every one of these, every particular ordered pair on that, that's why you graph a line, because that line represents every single ordered pair, every x, y, an infinite number of those that are solutions to the equation. Now, here's the game changer though, because we're talking about equations. And there is an infinite number, yes, for sure, of solutions. But you're kind of limited to just that particular straight line, however it actually goes. Here's the difference. Watch the screen. Watch closely. I'm not changing anything other than this. Bam. I made that now an inequality. So that's a linear inequality. This, back to this, is a linear equation. So I want you to understand what the solutions to the equation is, yes. But now let's go further and say, what's a solution to a linear inequality? We're not talking equality now, equals. We're talking something that's bigger than, or something that's less than, or greater than or equal to, or less than or equal to. And the best way I could tell you to really think about this would be with an equation of your age. So let's say we want to compare your age to other people's ages. So whatever your age is, I'll make it up. Let's say, for example, your age happens to be, I don't know, 15. Just make it up. So the question would be, how many people out there in the world would have an age that is exactly equal to your age? Well, you could certainly quantify it. You could totally count the amount of people. And I'm just going to make it up. Let's say out there in the world, there is, I don't know, 750,000 other people that have the same age as you. Now, let's not talk about the exact, time that you were born. You have the same birth date. My birth date's August 30th, so if I went out there and had to find out all the people that had the same birthday as me, there would be a lot of people. But here's the difference. What if I changed it now and said this? Well, if your age is still 15, now how many people out there in the world would actually have an age that is bigger than yours? So not equal to, not exactly equal to. So their age is actually more than you. So now we're not talking exactly, I messed this up a little bit. Yes, mine's August 30th, but the exact same year too. That's the same age as you. Same time, same birthday and year. But now we're talking not just the same, I don't care about August 30th. Now it's August 30th and anybody older than me. Well, certainly that means if you're thinking about this in your mind, there's going to be millions of people more in this world that are older than you. millions of people. What does that imply to you? Well, if I go back to this and I say, okay, here's my equation, and yes, even though I have an infinite number of solutions to this linear equation, what am I talking about if I go over to this and say, what are my solutions now to this particular linear inequality? Would all of these dots work? Yes, they would. However, there are going to be, as I'm implying to you with the age example, many, 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 many more than just being specific on that particular line. So, even though I'm talking about an infinite number with linear equations, you're going to have an infinite number with linear equalities. It's just going to look like it's more, and you'll see why. So let's dive into that so you can get a chance to figure out how this all works. So we're getting there, though. So here we go. I just kind of picked some random points here for you for this guy, and I want to show you how this kind of works. Because again, what I'm doing, as I plug these particular points in here, I want to see if it gives me a true inequality, if it actually does work. So if I take this point here, 0, 0, I'm going to put 0 in for x right here, so I get negative 3, times 0, plus put 0 in for y, 0, and I'm seeing if this is actually true. Is this over here does that all evaluate down to something that's bigger than or equal to 6? Well, let's do it. Negative 3 times 0 gives me 0, plus 0 gives me 0, so is that bigger than, is 0 bigger than or equal to 6? Well, is the alligator mouth eating the bigger number? No, so that would be bad. So this over here would not be a solution to this linear inequality. Well, let me get down here and try 2, 4. Let's get off of the origin. Let's go over here and go 2, 4. Let's try this one. See what happens. Well, let's put a 2 in for x. I'm going to put negative 3, 2. And I'll put a 4 in for y, so plus 4. Is that bigger than or equal to 6? I don't know. That is the question. Here we go. Negative 6 plus 4 gives me negative 2. Is that bigger than or equal to 6? No, that's bad as well. So this side over here, that guy right there, is not a solution. You know what? I just thought of this. What if I do this? Let me take this point here, negative 2, 0. If I put negative 2 in here for x, that gives me negative 3 times negative 2, plus 0 when I put a 0 in for y, because that's the ordered pair, negative 2, comma 0. Is that bigger than or equal to 6? Well, that gives me a negative 3 times negative 2 gives me 6. That gives me 6. Hey, that works, because 6 is equal to 6, so that is good. Which, by the way, that means that guy right there would be a solution to this linear inequality. Now let's jump off of the line and go on this side of it. That's what this guy's showing me. So negative 4, 5 is right there. Let's see if that's a solution. Negative 4 I put in for x. That gives me negative 3 times negative 4. I'll put a 5 in for y. That gives me plus 5. Is that bigger than or equal to 6? That is what I'm looking for. So I'm testing. Well, that gives me 12 here, because negative 3 times negative 4 gives me 12. Plus 5 gives me 17. So, oh, looky there. 17 is greater than or equal to 6. That is good. So what am I showing you? Well, I'm going to give you a couple more things. I'll show you a couple more points that's actually going to work. And in fact, you could do this too. I'll just tell you. If I took this point here, negative 5, 0, negative 5, 0, I put negative 5 in here and put 0 there, it would work. If I put negative 5, positive 3, it works. Negative 2, comma 4, it works. Negative 2, comma 7, it works. Negative 3, 0, it works. Negative 5, negative or 2 works. Negative 7, negative 4 works. Any of these, when you plug in those ordered pairs over there to the left, right here, for the x and the y, it gives you a true inequality. What am I showing you? Well, here's what I'm showing you. Not only are all of these actual ordered pairs on the line a solution to this inequality, linear inequality, everything that's over here is going to be a solution too. So what I'm going to do is I would shade everything on this particular side of that particular line. Because everything over here, now I could put a whole bunch of dots in there, but that's crazy. That's why we actually shade. So as you shade over here to the left, everything that I'm shading on this side of that particular line, they're all solutions to that particular linear inequality. So that certainly looks a lot different than the example that I showed you with the linear equation. Linear equation just has the solutions on the line. Linear inequality can be on the line or cannot be, but there certainly is going to be a lot more on one side or the other. So maybe you see where the Verizon network analogy is, maybe you don't. But we'll definitely get to it when I give you the next example in the steps. So there's your idea. So again, How do you graph linear inequalities? We're getting to that in the next video, but this is exactly what they look like. The difference between equation, you got this line that goes down through there that represents all of those order pairs that just work in that equation. But with a linear inequality, it looks similar, except there's going to be a lot more, because we're talking again about people out there in the world that have aged more than you as opposed to just equal to you. So here we go. Let's get to the video on the example.